ಶುರು ಮಾಡುವ.
ಎಸ್ ಸರ್ ಶುರು ಮಾಡೋಣ.
So I welcome to all of you. ಸೊ ಇಂದಿನ 64ನೇ ವಿದ್ಯಾರ್ಥಿ ಪ್ರತಿಭಾ ಶೋಧ ಯೋಜನೆಯ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ತಮ್ಮೆಲ್ಲರಿಗೂ ಸ್ವಾಗತ. ಸೊ ಅದರಲ್ಲಿ
ಹಲೋ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Am I audible? Students, am I audible? Yes, Swati, thank you. ಸರ್ ಶುರು ಮಾಡ್ಬೋದಾ ಕ್ಲಾಸ್? ವೆರಿ ಗುಡ್ ಈವ್ನಿಂಗ್ ಶಿವರಾಜ್. ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಸರ್? Sir, am I audible? Okay, students, let us start the session. Very good evening to all of you. Myself Abhishek, chemistry faculty in Base College, Mysuru. So last class we have started with respect to haloalkanes and haloarenes, and we started a discussion with respect to only haloalkanes, in which we discussed what are haloalkanes, then the classification of haloalkanes, then nomenclature of haloalkanes. Right, students?
ಹಲೋ ಹಲೋ ಹಲೋ
ಸರ್ ಕೇಳಿಸ್ತಿದ್ಯಾ?
ಇವಾಗ ಅವಾಗಿಂದ ಕೇಳಿಸ್ತಾನೆ ಇಲ್ಲ. ಸ್ವಲ್ಪ ನಾನು ನೋಡಿ ನಿಮಗೆ ನಾನು ಇದನ್ನು ಹೇಳ್ತಾ ಇದ್ದೆ ನಿಮ್ಮ ಬಗ್ಗೆ, ಅದನ್ನು ಸರಿಯಾಗಿ ಕನೆಕ್ಟ್ ಆಗ್ಲಿಲ್ಲ.
ಇಲ್ಲ, ಆಕ್ಚುಲಿ ನಾನು ಮಾತಾಡ್ತಾನೆ ಇದ್ದೆ, ಮಕ್ಕಳು ರೆಸ್ಪಾಂಡ್ ಮಾಡ್ತಾರೆ, ಕೇಳಿಸ್ತಾ ಇದೆ ಅಂದ್ರೆ ವಾಯ್ಸ್ ಬರ್ತಾ ಇದೆ ಅಂದ್ರು, ಮತ್ತೆ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತು
ಇಲ್ಲ
ಅನ್ಸುತ್ತೆ.
ಇಲ್ಲ ವಾಯ್ಸ್ ಬರ್ತಾ ಇರಲಿಲ್ಲ.
ಓಕೆ,
ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ಐ ವೆಲ್ಕಮ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸೊ ಓವರ್ ಟು ಯು ಸರ್.
Thank you, sir. Very good evening to one and all students. So myself Abhishek, working in Base College, Mysuru as a chemistry faculty. So last class we started with respect to haloalkanes and haloarenes, and ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದು haloalkanes ಬಗ್ಗೆ. ಅದರಲ್ಲಿ we discussed the definition of haloalkanes, the classification of haloalkanes, and the nomenclature of haloalkanes. Right, students? So previous session ಬಗ್ಗೆ ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದೆಯಾ with respect to classification, nomenclature, definition? Yes, students, do you have any doubts? Okay then. So today we will be discussing on the methods of preparations of haloalkanes, which is one of the very important concept as far as your board is concerned and the competitive exams are concerned. So let me begin with the methods of preparations of haloalkanes. Methods of preparations of haloalkanes. So just can you tell me what are the different methods by which you can prepare haloalkanes? Can any of you list out the methods? Yes, students, feel free. Let the session be interactive. Yes, Schwartz reaction, very good. Amele. Already I learned so much about the haloalkanes in your respective classes. So I want to know how much you know on the Darzin's process. Very good. Woods reaction. Woods reaction, yes, but it is not a method of preparations of haloalkanes. It's a chemical reaction shown by haloalkanes. Yes, so let us keep discussing now. Let me list out the method, then we'll discuss one by one. The first method from which you can prepare haloalkanes is from alcohols. Preparation of haloalkanes from alcohols, then preparation of haloalkanes from alkanes, then from alkenes, and another important method that is from halogen exchange methods. Halogen exchange methods. Okay, so these are the very four important reactions or preparation methods of preparations from which you're going to prepare haloalkanes. Students, is the handwriting visible or should I write in bigger font? Yes, students, visible. Okay, thank you. So let me take up the very first method of preparations of haloalkanes, that is from alcohols. So can anybody tell me what is the general formula of alcohol? Yes, general formula of alcohols. Anyone in the class? The general formula of alcohol, correct Swati, it is ROH. Yes, Shivraj, it is ROH. ROH. What is R? R is nothing but an alkyl group. It can be methyl, ethyl, propyl, butyl, isobutyl, whatever it is. So where R is an alkyl group. So by using alcohol, that is ROH, you have to prepare an haloalkane now. So what is the general formula of haloalkane that we discussed in the last session? Yes? General formula or general representation of an haloalkane. Very good. It is X. It is X. So if you carefully observe, from alcohol to alkyl halide or haloalkane, the change is the OH group is being replaced by halogen atom. Okay now? Therefore, with respect to this conversion of alcohol into haloalkane or alkyl halide, I must use another reagent which has an halogen. Correct, Allah? It can be chlorine, it can be bromine, iodine, any halogen atom. So now can you just tell me what are the different sources of that halogen which can be used to prepare haloalkane reacting with alcohol? ಯಾವ್ದೆಲ್ಲ the reactants which contains halogens use ಮಾಡಿ alcohol ಜೊತೆ ನಾವು alcohol ಜೊತೆ react ಮಾಡಿ we can get haloalkane. That's my question. Can you think of some reagents? Yes, students? So we can take hydrogen halides such as HCl, HBr, HI ತಗೊಳ್ಬಹುದು. We can use phosphorus halides such as phosphorus trihalides, phosphorus pentachloride. Then we can use thionyl chloride. So these are some of the important sources of halogen reactants which reacts with alcohol to form haloalkane. Okay, na? So adralli I'll be taking the first one, that is reaction of alcohol with hydrogen halides, which is given by the general formula HX, where HX is nothing but here I can take HCl, HBr, and HI. So these are the three very important hydrogen halides which can be reacting with alcohol. Okay, na? So now let me take the general reaction. If you take alcohol or OH, this upon reacting with HCl. So what do we get, students? Any guesses? When an alcohol reacts with HCl, what do we get? Yes? Anybody in the class? Very good. It is RCl. We are gonna get RCl plus what is the byproduct? The byproduct formed here will be water, that is H2O. So when an alcohol reacts with hydrogen halide, there will be formation of respective haloalkanes and the byproduct will be water. But the reaction of alcohol with HCl is taken in the presence of an important catalyst, which is nothing but anhydrous zinc chloride. Anhydrous zinc chloride. So this mixture HCl, and usually we prefer concentrated HCl here. The mixture of concentrated HCl and anhydrous zinc chloride is known as what? Yes, students? This is important for your practical exam, whether it's Viva and other competitive exams. The mixture of concentrated HCl and anhydrous zinc chloride. What is the name? Enanta karitira? Very good. Very good, Netra. It is called Lucas reagent. Lucas reagent. One of the very important reagent. So mixture of concentrated HCl and anhydrous zinc chloride is known as Lucas reagent. Important for your board exams for one fill in the blanks irbodu athwa MCQs ಅಲ್ಲಿ irbodu ಕೇಳ್ತಾರೆ ಅಥವಾ 1 marker ಅಲ್ಲಿ ಕೇಳಬಹುದು ಅಥವಾ any competitive exam it is important. Do make a note, students. So alcohol reacts with Lucas reagent to form chloroalkane. This is chloroalkane. Correct? And this reaction has a name. Reaction of alcohol with Lucas reagent, we call it as Groove's process. It is known as Groove's process. Do make a note. Can you just try to write some examples for this reaction? Yes? Some examples, students. What are the different examples you can take for this reaction? Anybody? Please, students. Ethyl alcohol. Lakshmi, correct? Let me take ethyl alcohol, that is CH3, CH2, OH. Ethyl alcohol, which is known as ethanol. IUPAC name of ethyl alcohol is ethanol. Reacts with HCl in the presence of anhydrous zinc chloride. And we're going to heat this mixture. Since we have taken a primary alcohol, we need to heat the mixture. So what do we get? What do we get? Ethanol reacts with HCl in the presence of anhydrous zinc chloride to give. Make it as simple as possible. So remove water from here, these two. So OH of that is alcohol and H of HCl will combine to form water, and the product obtained will be very good. It is ethyl chloride plus H2O. We get ethyl chloride plus H2O. IUPAC name of ethyl chloride is chloroethane. It's chloroethane. Is that clear? Is that clear, students? Yes. Similarly, we can prepare bromoalkanes. Bromoalkanes by using alcohol. So the question is, How do you prepare that bromoalkanes from alcohols? Hagadre, what is the other reactant that must be used to react with alcohol to get bromoalkane? Helboda? The other reactant to be used to prepare bromoalkane from alcohol. Alcohol in the bromoalkane beku. So what is the name of that hydrogen halide to be used for such reaction? Yes? It should contain bromine, correct? So name that hydrogen halide which contain bromine. That is HBr, hydrogen bromide. Very good. So when an alcohol, that is ROH, reacts with HBr, upon heating this mixture, so what do we get now? What do we get? There will be a elimination of water, that is byproduct, and there will be formation of the product, that is RBr, that is bromoalkane. Bromoalkane. Yes, but this preparation of bromoalkane from alcohol can also be achieved by another reaction wherein you can prepare hydrogen bromide instantaneously. Within the reaction mixture, you can prepare hydrogen bromide, and that hydrogen bromide can be reacted with alcohol to form bromoalkane. Okay, na? Andre, if you take a conical flask or beaker or round bottom flask for the reaction to happen, so ali we have to prepare HBr instantaneously. ಆ ಮೊಮೆಂಟಲ್ಲಿ ಆ ಕ್ಷಣಕ್ಕೆ ನನಗೆ HBr ಬೇಕು. ಓಕೆನಾ? ಸೊ ಅದನ್ನ we can prepare instantaneously. That formed HBr can be made to react with alcohol. ಅದನ್ನ ಹೇಗೆ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we make use of either sodium bromide or potassium bromide, that is NaBr ಅಥವಾ KBr, ಎರಡರಲ್ಲಿ ಒಂದು ಯೂಸ್ ಮಾಡ್ತೀವಿ. That is made to react with sulfuric acid, that is H2SO4. So when NaBr reacts with H2SO4, so tell me ಏನ್ ಬರುತ್ತೆ ಅಂತ? Anybody? When NaBr reacts with H2SO4, ಏನ್ ಬರುತ್ತೆ? Yes, there will be formation of HBr plus NaHSO4, that is sodium hydrogen sulfate. Sodium hydrogen sulfate, NaHSO4 ಅಥವಾ sodium bisulfate and HBr ಬರುತ್ತೆ. So that HBr will now react with alcohol. The HBr formed will now react with alcohol to produce RBr plus H2O. Okay, na? Such reactions wherein you prepare the required attacking reagent, that was a reactant, within the reaction mixture, we call it as in situ reactions. In situ reaction ಅಂತ ಕರಿತೀವಿ. In situ ಅಂದ್ರೆ instantaneously ಆ reaction ಅಲ್ಲಿ ನಾವು prepare ಮಾಡ್ಕೊಳ್ತೀವಿ. So HBr is prepared instantaneously within the reaction. ಓಕೆನಾ? So such reactions ನ ನಾವು in situ reaction ಅಂತ ಕರಿತೀವಿ. Any doubts with the students? Do you have any doubts? Okay, let's take an example for this. CH3, CH3 to the second carbon, there is OH group. Can you name the reactant? Yes, students? Name the reactant. Very good. Propane to all. It is propane to all. Very good. So when propane to all reacts with HBr, upon heating this mixture, ಏನ್ ಬರುತ್ತೆ? Yes, Pooja? ಹೇಳ್ತೀರಾ ಏನ್ ಬರುತ್ತೆ product? We get CH3, CH, CH3. The second carbon, the bromine will be bonded. And there will be a formation of H2O as a byproduct. So can you tell me the name of the product now? bromopropane. Which bromopropane? You should be particular. Very good, Pooja. It is 2-bromopropane. It is 2-bromopropane. Very good. Any doubts? Any doubts with this reaction, students? Similarly, so in addition to preparation of chloroalkanes and bromoalkanes by using alcohols, you can also prepare iodoalkanes using the same alcohol. But the question is, ಹಾಗಾದ್ರೆ to get iodoalkane as a product, that is, I have to convert an alcohol into iodoalkane, that is Ri. So can you tell me what is the other reactant to be used now? Yes, students. The other reactant that can be used. Which iodide? Yes, Shivraj, hydrogen iodide, that is Hi. So alcohol reacts with hydrogen iodide. So there will be a formation of iodoalkane, Ri, and the other product, that is byproduct form, will be water. Okay, now? Again, this formation of Hi, that is attacking reagent Hi, can be prepared instantaneously within the reaction mixture. And within the reaction container, we can prepare hydrogen iodide. So can you tell me a method where you can prepare hydrogen iodide instantaneously? And in situ reactions. ಹೇಳ್ಬೋದಾ? Yes. So we make use of potassium iodide salt, that is Ki use ಮಾಡ್ತೀವಿ. So that Ki is now made to react with phosphoric acid, that is H3PO4. Upon heating this mixture, what do we get? Guess ಮಾಡಬೇಕು. Ki plus H3PO4. What do we get? Hi ಬರುತ್ತೆ plus KH2PO4, that is potassium dihydrogen phosphate. Okay, na? So that Hi which is synthesized within the reaction mixture, which is prepared within the reaction mixture, it can be now made to react with the alcohol such as propane through all. Okay, so reacts with hydrogen iodide to form what? What is the product now? The OH is replaced by the iodine. It is replaced by iodine. Therefore, we get the product 2-iodopropane. So ನೀವು ಒಂದು ರಿಯಾಕ್ಷನ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ರಿಮೈನಿಂಗ್ ರಿಯಾಕ್ಷನ್ಸ್ ಎಲ್ಲ ಈಸಿ ಆಗುತ್ತೆ. So listen carefully and do make a note of whatever the reactions we write here. Okay na? Yes, Shivraj, very good. 2-iodopropane ಆಗ್ಬೇಕು ಅದು. ಟೈಪಿಂಗ್ ಎರರ್ ಅನ್ಸುತ್ತೆ. You have written as propene. Any doubts? Yes. Now this is with respect to board part, the preparation of chloroalkane, bromoalkane and iodoalkane from alcohols. But how the questions will be asked in competitive exams such as JE, NEET and CET. Okay na? Istu straight ಆಗಿ ಕೇಳೋದಿಲ್ಲ. Instead they'll ask in terms of application level. ಹೇಗೆ? Suppose if you take one particular alcohol, if you keep changing the different hydrogen halides, ಅವಾಗ which hydrogen halide will react more easily with a given alcohol? That is how the question will be asked. Okay na? For example, ಈಗ I will be taking ethanol as an alcohol. Fix ಮಾಡ್ಕೊಳ್ತೀನಿ. Ethanol fix ಮಾಡಿ, but I am using 3 different hydrogen halides such as HCl use ಮಾಡ್ತೀನಿ, HBr use ಮಾಡ್ತೀನಿ and HI use ಮಾಡ್ತೀನಿ. Okay na? Of course ಎಲ್ಲ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. I get ethanol ಇಂದ HCl react ಆಗಿ we get ethyl chloride ಬರುತ್ತೆ, no doubt. Then HBr reacts with ethanol to form bromoethane ಅಥವಾ ethyl bromide. Similarly, ethanol reacts with HI to form ethyl iodide ಬರುತ್ತೆ, ಏನೂ ಡೌಟ್ ಇಲ್ಲ. But the question is, among HCl, HBr and HI, which will react more easily with the given alcohol? So what is the order of reactivity of these hydrogen halides? ಹೇಳ್ಬಹುದಾ? Can you just think and answer? Among HCl, HBr and HI, which will easily react with the given alcohol. Shivraj, ಯೋಚನೆ ಮಾಡಿ ಆನ್ಸರ್ ಮಾಡಿ. So the one which contains iodine, that is HI. Why? That's right. Order of reactivity. Order of reactivity is HI greater than HBr greater than HCl. ಯಾಕೆ? Any guesses? The order of reactivity HI is greater than HBr greater than HCl. ಯಾಕೆ? Make it more interactive, students. Nature of bond. So what do you mean by nature of bond, Netravati? Now students, so here the OH group is replaced by chlorine, Br and iodine atoms. That means the bond between HCl, HBr and HI should be broken first. ಹಾಗಾದ್ರೆ ಯಾವುದು ಬಾಂಡ್ ಈಸಿಯಾಗಿ ಬ್ರೇಕ್ ಆಗುತ್ತೆ? HCl ಬಾಂಡ್ ಈಸಿ ಬ್ರೇಕ್ ಆಗುತ್ತಾ? HBr ಬಾಂಡ್ ಈಸಿ ಬ್ರೇಕ್ ಆಗುತ್ತಾ? ಅಥವಾ HI ಬಾಂಡ್ ಈಸಿಯಾಗಿ ಬ್ರೇಕ್ ಆಗುತ್ತಾ? ಸೊ ಯಾವ್ದನ್ನ ಈಸಿಯಾಗಿ ಬ್ರೇಕ್ ಮಾಡ್ತೀವಲ್ಲ, ಸೊ ಅದು ಬೇಗ ರಿಯಾಕ್ಟ್ ಆಗತ್ತೆ ವಿತ್ ಅ ಗಿವನ್ ಆಲ್ಕೋಹಾಲ್. ಸೊ ಯಾವ್ದು ಅವಾಗ? ಎಸ್ ಜ್ಯೋತಿ, ಯು ಆರ್ ರೈಟ್, ದಟ್ ಈಸ್ HI. ಯಾಕೆಂದ್ರೆ ದ ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ಅಥವಾ ದ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ಬ್ರೇಕ್ ದ ಬಾಂಡ್ HI ವಿಲ್ ಬಿ ಲೆಸ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಬಾಂಡ್ ಎನರ್ಜಿ ಅಥವಾ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎನರ್ಜಿ. Bond dissociation energy of HI is less than HBr, less than HCl, less than HF. So since the bond dissociation energy of hydrogen iodide is less, and the ಸ್ವಲ್ಪ energy in the, you can aramse break the bond between H and iodine. Correct alla? Therefore it will react very much easily with the given alcohol. Did I make this clear? So this is how the competitive question will be asked, students. ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. Do you have any doubts? Yes, students? ಡೌಟ್ ಇದೆಯಾ? Yes, thank you. Now, change ಮಾಡೋಣ ಇವಾಗ. I'll be keeping one of the hydrogen halide HCl ಫಿಕ್ಸ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಇಲ್ಲ HBr ಇಲ್ಲ HI ಫಿಕ್ಸ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. I will be changing the alcohol. Okay na? When I say alcohol, there are different types of alcohol depending on the type of carbon to which OH group is bonded. Andre if OH group is bonded to a primary carbon, what is the name of the alcohol given, students? ಏನಂತ ಕರೀತೀರಾ alcohol ನ? If OH group is bonded to a primary carbon, ಏನಂತ ಕರೀತೀರಾ? Very good Swati. It is primary alcohol. Correct? For example, ethanol ಇದೆ, which is a primary alcohol because OH group is bonded to a carbon and that carbon is bonded to another carbon and therefore this carbon is a primary carbon. Let me take another example, CH3, CH, CH3, OH. So OH group is bonded to a carbon which in turn is bonded to two other carbons. Therefore this carbon is known as secondary now. Therefore OH group bonded to secondary carbon and such alcohols are secondary alcohols. One more example, CH3, CCH3, CH3, this is OH. So OH group is bonded to a carbon and that carbon is bonded to three other carbons. Therefore this carbon is a tertiary carbon and such alcohols are called tertiary alcohol. So therefore this is first one is primary alcohol, this is secondary alcohol and this is tertiary alcohol. ಈಗ ನನ್ನ ಪ್ರಶ್ನೆ, among these three alcohols, which alcohol is more reactive towards a given hydrogen halide? HCl ಇರ್ಬೋದು, HBr ಇರ್ಬೋದು ಅಥವಾ HI ಇರ್ಬೋದು. ಯಾವುದು ಈಸಿಯಾಗಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ? ವೆರಿ ಗುಡ್ ಪೂಜಾ, ವೆರಿ ಗುಡ್. It is tertiary alcohol. The order of reactivity of alcohol is tertiary alcohols are more reactive than secondary alcohols, which are more reactive than primary alcohols. This is very, very, very important for your competitive exams. Do make a note. ಯಾಕೆಂದ್ರೆ the tertiary alcohol is more polar. It is more polar and forms tertiary carbocation, which is more stable compared to secondary, compared to primary. So tertiary carbocation is more stable than secondary carbocation, more stable than primary carbocation. And in this reaction of alcohol with hydrogen halides, there will be a formation of carbocation. So ಯಾವ carbocation more stable ಇರುತ್ತೆ ಅದು first form ಆಗುತ್ತೆ. Therefore the reaction will be faster. Okay na? Therefore tertiary alcohols are more reactive than secondary alcohols, which are more reactive than primary alcohols. It is more reactive than methanol, CH3OH. Any doubts with this? Any doubts with this reaction, students? Any doubts? Yes. Let's continue now. The next method of preparation, alcohol, that is sorry, haloalkanes, using same alcohol. Okay. So here I'll be using the second one, that is reaction of alcohols with phosphorus trihalides. Reaction of alcohols with phosphorus trihalides. When I say phosphorus trihalides, it is PCl3, PBr3 and Pi3. Okay na? So these are the phosphorus trihalides that we use here for the preparation of different haloalkanes. So what happens when an alcohol reacts with this phosphorus trihalide such as PX3? ಹೇಳ್ತೀರಾ? Can you just guess? What do we get the product and the alcohol reacts with phosphorus trihalide to give? So what am I preparing now? I am preparing haloalkane. And what is the formula of haloalkane? Yes, the general formula RX ಬರುತ್ತೆ. Very good. We get X plus byproduct ಬೇಕಲ್ವಾ? What is the other byproduct that we get now? Yes? Is it POCl3? Yes, students? Answer ಮಾಡಬೇಕು. Answer ಮಾಡಬೇಕು. Is it POCl3? It is not POCl3. We get H3PO3. H3PO3 byproduct ಬರುತ್ತೆ ನಿಮ್ಗೆ, which is phosphorus acid. This is phosphorus acid. And this is haloalkane. So balance ಮಾಡ್ಬೇಕು ಇವಾಗ ನೀವು. So ಹೇಳ್ತೀರಾ balance ಹೇಗೆ ಮಾಡ್ತೀರಾ ಅಂತ? I have ROH PX3. So ಇಲ್ಲಿ 3 halogen ಇದೆ. So react product side ಅಲ್ಲಿ ಕೂಡ 3 halogen ಬೇಕು. Therefore I multiply this RX by 3. ಅವಾಗ 3 RX ಆಗುತ್ತೆ, halogen balance ಆಗುತ್ತೆ. But ಇಲ್ಲಿ 1 R ಇದೆ, ಇಲ್ಲಿ 3 R group ಇದೆ. Therefore this I have to multiply by 3. So 3 moles of alcohols reacts with PX3 to form 3 moles of alkyl halide ಅಥವಾ haloalkane plus H3PO3. Is that clear? Is that clear? Let's take example for this. I have CH3, CH2, OH, ethanol ತಗೊಂಡಿದ್ದೀನಿ. To that, I will be adding PCl3 now. PCl3, phosphorus trichloride. So upon heating this mixture, ಏನ್ product ಬರುತ್ತೆ? I have taken 3 moles of ethanol plus PCl3. What do we get? We get 3 moles of CH3, CH2, Cl plus H3PO3 plus H3PO3. Very good. It is chloroethane. We get chloroethane. ಹಾಗೆ how to prepare bromoethane from by this method? Anybody? ನಂಗೆ ಬ್ರೋಮೋಇಥೇನ್ ಬೇಕು. ಏನ್ ಯೂಸ್ ಮಾಡ್ಬೇಕು ಅವಾಗ? ethanol ಇಂದ bromoethane. So what is the other reactant to be used? It is the attacking reagent now. ಹೇಳ್ತೀರಾ? Very good, Pooja. It is PBr3. PBr3. So 3 moles of ethanol, Ca3CH2OH reacts with PBr3, phosphorus tribromide. But ಇಲ್ಲಿ this phosphorus tribromide ಇದೆಯಲ್ಲ, that is quite unstable and it cannot be stored easily. ಹಾಗಿದ್ದಾಗ so how to prepare that PBr3? ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೋತೀರಾ? I'm telling you this PBr3 is quite unstable. ಹಾಗಿದ್ದಾಗ ನಾವು ಹಿಂದೆನೆ ಪ್ರಿಪೇರ್ ಮಾಡಿರೋ PBr3 ಯೂಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. And we cannot add that PBr3 to ethanol directly. PBr3 is quite unstable. Because of that reason ನಾವು ಅದನ್ನ ಮುಂಚೆ ಯಾವಾಗ್ಲೋ ಮಾಡಿದ ಪ್ರಿಪೇರ್ ಮಾಡಿದ PBr3 ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. But I want the reaction to happen easily. ಹಾಗಿದ್ದಾಗ I have to prepare PBr3 at the requirement. ಅಂದ್ರೆ instantaneous and prepare ಮಾಡ್ಕೊಳ್ಬೇಕು. And what do you call that reactions? Where you prepare that like attacking reagent within the reaction mixture and made to react with the given substrate. What do you call such reactions? ಸ್ವಲ್ಪ ಹೊತ್ತು ಮುಂಚೆ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ. Yes, students. ಆನ್ಸರ್ ಬರಬೇಕು. That is in situ reactions. We have to prepare the PBr3 instantaneously. That is in situ reaction. So ಹೇಗೆ prepare ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ we take red phosphorus, that is P4, and it is made to react with bromine. So when red phosphorus is made to react with bromine, there will be formation of PBr3. So that PBr3 obtained by the reaction between red phosphorus and bromine will now react with ethanol to form CH3 CH2 Br plus H3PO3. So one general reaction ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಎಲ್ಲ ಅದರ್ ರಿಯಾಕ್ಷನ್ಸ್ ಈಸಿ ಆಗುತ್ತೆ. ಓಕೆನಾ? ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ ಸ್ಟೂಡೆಂಟ್ಸ್? Yes. Let's continue. So now I want to prepare iodoalkane by using alcohol. Okay na? And can you think of the phosphorus trihalide which can be used to react with alcohol to get iodoalkane? ಆಲ್ಕೋಹಾಲ್ ಜೊತೆ ಯಾವ ಅದರ್ ರಿಯಾಕ್ಟೆಂಟ್ ರಿಯಾಕ್ಟ್ ಆದ್ರೆ ನಿಮ್ಗೆ iodoalkane ಬರುತ್ತೆ? Very good. It is PI3, phosphorus triiodide. So let me take the same example. CH3CH2OH will now react with PI3, phosphorus triiodide. Once again, this PI3 is unstable and it cannot be stored easily. ಆಯ್ತಾ? ಹಾಗಿದ್ದಾಗ once again how to make this reaction possible? ಈಸಿಯಾಗಿ ಯಾವುದೇ ಗ್ಲಿಚಸ್ ಇಲ್ಲದೆ ಹೇಗೆ ಮಾಡ್ಬೋದು? Yes, students? ಹೇಗೆ ಮಾಡ್ತೀರಾ? ನಾನು ಮುಂಚೆನೆ ಫಾಸ್ಫರಸ್ ಟ್ರೈಐಯೋಡೈಡ್ ದಟ್ ಇಸ್ PI3 ನ ಪ್ರಿಪೇರ್ ಮಾಡಿ ಇಟ್ಕೊಳಕ್ ಆಗಲ್ಲ. ಯಾಕೆ ಅಂದ್ರೆ ಅದು ಅನ್ಸ್ಟೇಬಲ್. ಅದು ಅನ್ಸ್ಟೇಬಲ್ ಆದ್ರೆ ಅದು ಆಲ್ಕೋಹಾಲ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ ಅಂಡ್ ನಮ್ಗೆ iodoalkane ಬರಲ್ಲ. ಓಕೆನಾ? ಸೊ ಹಾಗಿದ್ರೆ ಹೌ ಪ್ರಿಪೇರ್ ದಟ್ iodoalkane ಬೈ ಯೂಸಿಂಗ್ ಆಲ್ಕೋಹಾಲ್ ಅಂಡ್ PI3? ಏನ್ ಮಾಡ್ಬೇಕು? ಎನಿಬಡಿ? ಐ ಆಮ್ ಎಕ್ಸ್ಪೆಕ್ಟಿಂಗ್ ದ ಆನ್ಸರ್. We have to prepare PI3 instantaneously depending on the requirement. Once again, we have to go for in situ. So, illi the red phosphorus is made to react with iodine. So, when P4 and iodine react, there will be formation of PI3 barata. Okay, na? So, that PI3 will react with alcohol and we get the product that is CH3 CH2I plus H3PO3. So we get iodoalkane as a product. Is that clear? Iodoalkane. So this is how we prepare different haloalkanes by using phosphorus trihalide, that is PX3. So we use PCl3, PBr3 and PI3. PBr3 and PI3, they are quite unstable to be stored. Therefore, these two reactant, that is PBr3 and PI3, has to be prepared instantaneously. Andre in situ reactions now carry ಮಾಡ್ತೀವಿ. Okay na? Well, let me take the next one. That is reaction of alcohols with phosphorus pentahalide, such as PCl5. That is phosphorus pentachloride ಜೊತೆ ಆಲ್ಕೋಹಾಲ್ ನ ರಿಯಾಕ್ಟ್ ಮಾಡೋಣ. ಏನ್ ಬರುತ್ತೆ ನೋಡೋಣ ಈಗ. ಹೇಳ್ತೀರಾ? When alcohol reacts with phosphorus pentahalide, what do we get? Yes, students. Alcohol reacts with phosphorus pentachloride. ನನಗೆ ಪ್ರಾಡಕ್ಟ್ ಬೇಕು. Yes, of course you are right. Tejaswini, we get POCl3 ಬರುತ್ತೆ. Yes, Shivraj, we get PCl5 ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So we get RCl plus. Observe ಮಾಡಿ, this PCl5 ನ I can break like this. So Cl, PCl3, Cl ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ. So PCl5 together. So now we are getting Cl. So one chlorine ಎಲ್ಲಿಗೆ ಹಾಕೋಣ? So R and Cl combine ಆಗುತ್ತೆ. ಇನ್ನೊಂದು ಕ್ಲೋರಿನ್ ನಾನು H ಜೊತೆ ಆಡ್ ಮಾಡ್ತೀನಿ. We get HCl ಬರುತ್ತೆ. This PCl3 will now react with oxygen. So oxygen and PCl3 react ಆಗುತ್ತೆ. Therefore we get POCl3 and other will be HCl. So we get RCl, POCl3 and HCl. Okay na? Is that clear? Is that clear? So this POCl3 is called as phosphoryl chloride. Phosphoryl chloride ಅಂತ ಕರಿತೀವಿ. Is that clear? ಅಥವಾ phosphorus oxychloride ಅಂತಾನೂ ಕರೀತಾರೆ. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Phosphoryl chloride ಅಥವಾ phosphorus oxychloride. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೋಣ. So we have CH3, CH, CH3, OH ಇದೆ. ಇದಕ್ಕೆ I am treating with PCl5 to heat the reaction mixture, students. So heat ಮಾಡಿದಾಗ what do we get? ಹೇಳ್ಬೋದಾ? ಫಾಸ್ಟ್ ಆಗಿ. So alcohol reacts with PCl5 to form CH3, CH, CH3. We get Cl plus POCl3, phosphorus oxychloride ಅಥವಾ phosphoryl chloride plus HCl. So from propane to all ಇಂದ we can prepare 2-chloropropane. 2-chloropropane. Is this clear? Is this clear to everybody? Any doubts? Any doubts? Okay, so this is another reaction where you can prepare haloalkanes. That is, especially we can prepare chloroalkane using PCl5. ಹಾಗಿದ್ರೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಇದೆ, ಬ್ರೋಮೋ ಆಲ್ಕೇನ್ ಮತ್ತೆ ಅಯೋಡೋ ಆಲ್ಕೇನ್ ನ ಈ ಮೆಥಡ್ ಇಂದ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದಾ? To prepare bromo alkane and iodo alkane, instead of PCl5 we have to use PBr5 and PI5. But remember, you cannot prepare. ಯಾಕೆ ಅಂದ್ರೆ PBr5 and PI5 are highly unstable. They are unstable. Since they are unstable, they cannot be used and they cannot be made to react with alcohol to get respective haloalkanes. So we prepare only fluoroalkane by using PCl5 upon reacting with alcohol. This is a competitive part. Do remember this, students. Let me take the last reaction from which you can prepare haloalkane by using alcohol. That is reaction of alcohol with thionyl chloride. Thionyl chloride, that is SOCl2. Thionyl chloride. Very important reaction. So illi, I'll be using alcohol as the reactant, and the attacking reagent here is we use thionyl chloride SOCl2 in the presence of pyridine. There is a solvent here. So ಏನಾಗುತ್ತೆ ಹೇಳ್ತೀರಾ? Once again, this SOCl2 na I can split as Cl SOCl ಅಂತ split ಮಾಡ್ಕೊಳ್ಳೋಣ. So ಏನ್ ಬರುತ್ತೆ ಯೋಚನೆ ಮಾಡ್ತೀರಾ? ಪ್ರಾಡಕ್ಟ್ ಹೇಳ್ಬೋದಾ? Very good, we get RCl SO2. Very good. ಆಮೇಲೆ we get RCl SO2 and HCl. Very good. So we get chloroalkane plus SO2 plus HCl. Chloroalkane. Okay na? And this process of preparations of chloroalkane by using thionyl chloride is known as Darzon's reaction. This is known as Darzon's process or Darzon reaction. Very important. Do make a note. ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ the byproduct what we get is sulfur dioxide, which is a gas, and HCl, which is also a gas. Okay na? So that can be easily removed from the product. Therefore ನಿಮ್ಗೆ extra separation techniques ಎಲ್ಲ ಏನು ಅವಶ್ಯಕತೆ ಇರೋದಿಲ್ಲ. We can get pure chloroalkane because the other byproducts formed here, that is SO2 and HCl, they're gaseous in nature. Okay na? Any doubts? Take an example for this. Ethanol ತಗೊಂಡಿದ್ದೀನಿ. To that ethanol we are adding thionyl chloride now in the presence of pyridine. ಏನ್ ಬರುತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಹೇಳ್ತೀರಾ ಬೇಗ? Yes, students, what do we get? CH3 CH2 Cl plus SO2 plus HCl. We get chloroethane as a product. Chloroethane. This is Darzon's process, one of the very important process for your competitive exams and also for your board exam. Do remember. Any doubts? Any doubts with respect to this Darzon's process and the preparation of haloalkanes from alcohols? So ಇಲ್ಲಿವರೆಗೆ ನಾವೇನೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ಅದನ್ನೆಲ್ಲ ನೀವು ಒಂದು ಸಮ್ಮರಿ ಶೀಟ್ ತರ ಮಾಡಬೇಕು ಆಯ್ತಾ? ಸೊ ಎಲ್ಲ ಆಲ್ಕೋಹಾಲ್ಸ್ ಇಂದಾನೆ we have used different reactants. hydrogen halide ಯೂಸ್ ಮಾಡಿದ್ವಿ, PX3 ಯೂಸ್ ಮಾಡಿದ್ವಿ, PC alpha ಯೂಸ್ ಮಾಡಿದ್ವಿ and SOCl2 ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಬಟ್ ಆಲ್ಕೋಹಾಲ್ ಸೇಮ್ ರಿಯಾಕ್ಟೆಂಟ್ ಬಟ್ ಡಿಫರೆಂಟ್ ಅದರ್ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯೇಜೆಂಟ್ಸ್. ಸೊ ಇದ್ದಾಗ ನಿಮ್ಗೆ ಏನೆಲ್ಲ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬರುತ್ತೆ ಅಂಡ್ ಬೈ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬರುತ್ತೆ ಎಲ್ಲ ಒಂದು ಮೈಂಡ್ ಮ್ಯಾಪಿಂಗ್ ತರ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ. ದಾಟ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪ್ಫುಲ್ ಫಾರ್ ಪ್ರಿಪರೇಷನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಯುವರ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ and also for your competitive exams. Okay na? Well, let me go for the second method of preparation of haloalkane, that is from alkanes. Okay? For example, I'll be taking methane, CH4 ತಗೊಂಡಿದ್ದೀನಿ ನಾನಿಲ್ಲಿ, which is the best example and the first member of hydrocarbon, that is alkane, that is methane. So methane in the I want to prepare an haloalkane. For example, I want to prepare chloromethane. The formula is CH3Cl. ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀರಾ ಹೇಳ್ಬೋದಾ? Yes, students. CH4 in the CH3Cl. If you carefully observe, one of the hydrogen atom is replaced by an halogen, which is chlorine. And then ಏನು add ಮಾಡ್ಬೇಕಿಲ್ಲಿ? Another reactant. CH4 should be made to react with what? Yes. It should react with chlorine molecule, Cl2. So when methane is made to react with chlorine in the presence of sunlight, ಅಥವಾ heat ಮಾಡ್ಬೋದು ಕೂಡ, in the presence of sunlight or heat, one of the hydrogen will be replaced by chlorine and the byproduct we're going to get is HCl. HCl ಆಚೆ ಹೋಗುತ್ತೆ minus HCl. Correct? Further, this CH3Cl, which is nothing but chloromethane, has 3 more replaceable hydrogens. ಸೊ ಇದನ್ನ ನೀವು ಮತ್ತೆ ಕ್ಲೋರಿನ್ ಜೊತೆ ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸನ್ಲೈಟ್ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ? CH3Cl plus chlorine in the presence of sunlight. ನಿಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ ಪ್ರಾಡಕ್ಟ್? Yes, we get CH2Cl2 and once again ಇಲ್ಲಿ ಒಂದು HCl ಆಚೆ ಹೋಗುತ್ತೆ. ಕರೆಕ್ಟಾ? Yes, very good ಶಿವರಾಜ್. ಮತ್ತೆ CH2Cl2 ನಲ್ಲಿ there are two more replaceable hydrogens which can be made to react with chlorine in the presence of sunlight ಅಥವಾ heat. We get CHCl3, which is trichloromethane, which is commonly called chloroform. Okay na? Matte this chloroform can be made to react with chlorine in the presence of sunlight athwa heat to produce CCl4, and there will be a loss of HCl. Correct? Yes or no, students? So here what exactly is happening? The hydrogen atom is replaced by halogen atom. Therefore, what is the type of reaction it is? Can you name the type of reaction? Anybody in the class? Bega. What type of reaction it is? ಇದನ್ನ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲೂ ಕಲ್ತಿದ್ದೀರಾ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ. Yes, hydrogen is replaced by halogen. So it is an example for a substitution reaction, and this substitution reactions follow via free radical formation. So ಇದನ್ನ free radical substitution reaction ಅಂತ ಕರಿತೀವಿ. Free radical substitution reaction, very very important for your competitive exam. Okay na? Any doubts? Any doubts? But I have a question for you now. Observe ಮಾಡಿ, ನನ್ನ ಹತ್ರ ಇಲ್ಲಿ CH3, CH2, CH3 ಇದೆ. ಓಕೆನಾ? Which is propane. Propane. ಇದಕ್ಕೆ I'm adding chlorine in the presence of sunlight. ಓಕೆನಾ? ಈಗ the question is, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಹೈಡ್ರೋಜನ್ಸ್ ಇದಾವೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. This is CH3, 3 hydrogens ಇದೆ, and ಇಲ್ಲೊಂದು CH3, 3 hydrogens ಇದೆ. This carbon is a primary carbon because it is bonded to another carbon. Again, this initial first carbon is bonded to another carbon. They say it is primary again. And what about the middle carbon? What type it is? The central carbon. What type of carbon it is? Very good. It is a secondary carbon. Now, the hydrogen which are bonded to primary carbon are called primary hydrogens, and the hydrogen which is bonded to secondary carbon are known as secondary hydrogens. Okay na? But the two primary carbons ನೀವು ಏನ್ ನೋಡ್ತಿದ್ದೀರಾ ಇಲ್ಲಿ, they are identical. ಒಂದೇ ತರ ಇದೆ. CH3 bonded to CH2, ಈ CH3 ಕೂಡ bonded to CH2. Therefore, they are identical. Okay na? ಹಾಗಿದ್ದಾಗ any one of the hydrogen from the primary carbon can be replaced. ಅಥವಾ out of 6 primary hydrogens together, ಇಲ್ಲಿ 3, ಇಲ್ಲಿ 3, ಎರಡು ಎಲ್ಲ identical ಇದೆ. So out of them, any one can be replaced and we get CH3, CH2, CH2, Cl. So ಈ ಕಾರ್ಬನ್ ಇರೋ ಒಂದು ಹೈಡ್ರೋಜನ್ ನಾನು ರೀಪ್ಲೇಸ್ ಮಾಡಿದೀನಿ Cl ಜೊತೆ. ಕರೆಕ್ಟಾ? ಹಾಗೆ ಬಟ್ ಇದೊಂದೇ ಪ್ರಾಡಕ್ಟ್ ಸಾಧ್ಯನಾ? Is it the only product that you can get from this reaction? Yes or no? Yes, students? No, correct. ಹಾಗಾದ್ರೆ ಇನ್ನೊಂದು ಪ್ರಾಡಕ್ಟ್ ಏನ್ ಬರಬಹುದು? ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಸೆಕೆಂಡರಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದೆ. Even that secondary hydrogen atom can be replaced by halogen. Therefore, ಏನ್ ಬರುತ್ತೆ ಅವಾಗ? If secondary hydrogen atom is replaced, we get CH3, CH, Cl, CH3. ಇದು ಬರುತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಆಗಿ. ಓಕೆನಾ? ಬಟ್ ದ ಕ್ವೆಶ್ಚನ್ ಇಸ್, ಎರಡೂ ನಿಮ್ಗೆ ಈಕ್ವಲ್ ಆಗಿ ಬರುತ್ತಾ? ಈಸ್ ಇಟ್ ಲೈಕ್ 50-50% ಈಚ್ ಬರುತ್ತಾ ಅಥವಾ ಇಲ್ವಾ? Do we obtain these products in equal proportion or not? No. Yes, Shivraj. ಹಾಗಾದ್ರೆ one will be in lesser quantity, the other will be in more quantity. The one which is in lesser quantity is minor product, the one which is more is major product. ಹಾಗಾದ್ರೆ ಇವೆರಡರಲ್ಲಿ ಯಾವುದು ಮೈನರ್ ಯಾವುದು ಮೇಜರ್? ಅದು ಇಂಪಾರ್ಟೆಂಟ್. ದ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಗೆ ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಹೇಳ್ಬೋದಾ? 1 ಕ್ಲೋರೋಪ್ರೋಪೇನ್ ಮೇಜರ ಮೈನರ ಅಥವಾ 2 ಕ್ಲೋರೋಪ್ರೋಪೇನ್ ಮೇಜರ ಮೈನರ? ಹೇಳ್ತೀರಾ? First one or second one? First or second? 2-chloropropane is major. Very good. Yake? 2-chloropropane is major, whereas 1-chloropropane is minor. Yake? Because when you consider the substitution reaction, that is free radical substitution reactions, always remember the order of reactivity of hydrogens. So order of reactivity is tertiary hydrogen is more reactive than secondary hydrogen, which is more reactive than primary hydrogen. So ನಾವು ತಗೊಂಡ್ರೆ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಸೆಕೆಂಡರಿ ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಪ್ರೈಮರಿ ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ. Reactivity wise ಯಾವುದು more reactive? Secondary hydrogen. Therefore secondary hydrogen will be easily replaced by chlorine atom. Therefore we get 2-chloropropane as a major product. ಅರ್ಥ ಆಯ್ತಾ? ಹಾಗೆ ಒಂದು ಹೋಮ್ವರ್ಕ್ ತಗೊಳ್ಳಿ. And you should predict the possible chloroalkanes and you should identify the major ones. So CH3, CH, CH3, CH2, CH3. ಇದನ್ನ ನಾನು ಕ್ಲೋರಿನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ವಿಚ್ ಇಸ್ ಮೋನೋಕ್ಲೋರಿನೇಷನ್. ಅಂದ್ರೆ 1 mole ಕ್ಲೋರಿನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ರಿಪ್ಲೇಸ್ ಆಗುತ್ತೆ. ಸೊ ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸನ್ಲೈಟ್ ನಿಮ್ಗೆ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅಂಡ್ ಯಾವುದು ಮೇಜರ್ ಅಂತ ನೀವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು. ದಿಸ್ ಇಸ್ ಹೋಮ್ ವರ್ಕ್ ಕ್ವೆಶ್ಚನ್. Is that clear? Hint ಕೊಡ್ತೀನಿ ನಾನು. You have to identify the type of hydrogens, type of carbons first, then type of hydrogens. ಅದಾದ್ಮೇಲೆ you should keep replacing the hydrogens and you should predict the products, number of products. ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ and ಅದರಲ್ಲಿ ಯಾವುದು ಮೇಜರ್. So that is a homework question. Okay na? Let me take the next one. The preparation of haloalkane, that is from alkenes, the third method. From alkenes. So alkenes ಅಂದ್ರೆ ಏನು? ಇದೆಲ್ಲ ಹೊಸದಲ್ಲ, ತುಂಬಾ ಫೆಮಿಲಿಯರ್ ಇದ್ದೀರಾ ನೀವು. Alkenes ಅಂದ್ರೆ there will be a carbon carbon double bond. For example, if I say RCH double bond CHR, ಇದು ಒಂದು ಆಲ್ಕಿನ್ ತಗೊಂಡಿದ್ದೀನಿ. ಇನ್ನೊಂದು RCH double bond CH2 ಅಂತ ಇನ್ನೊಂದು ತಗೊಂಡಿದ್ದೀನಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಓಕೆನಾ? If you look at these two alkenes, how are they different? Yes students, ಹೇಗೆ ಡಿಫ್ರೆಂಟ್ ಇದೆ ಹೇಳ್ಬೋದಾ? This double bond ಏನಿದೆ ಅಲ್ಲ, and if you look at the structure here, the molecule, it is symmetric. It is symmetric, symmetrical alkene ಅಂತ ಕರಿತೀವಿ. ಈ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ಏನ್ ತಗೊಂಡಿದ್ದೀನಿ, is it symmetric ಅಂತ ಅನ್ಸುತ್ತಾ? ನೀವು ನೋಡಿದ್ರೆ ಎರಡೂ ಕಡೆ ಸೇಮ್ ಅಂತ ಅನ್ಸುತ್ತಾ? ಇಲ್ಲಿ ನೋಡಿ, ಡಬಲ್ ಬಾಂಡ್ ಸಡನ್ ಆಗಿ ಇಟ್ಕೊಳ್ಳಿ, ಕಡೆ ಈ ಕಡೆ ನೋಡ್ರಿ ಎರಡು ಸೇಮ್ ಇದೆ. ಇಟ್ ಇಸ್ ಸಿಮೆಟ್ರಿಕ್. ಬಟ್ ಸೆಕೆಂಡ್ ಮಾಲಿಕ್ಯೂಲ್ ಇಲ್ಲ, ಸೊ ಇಟ್ ಈಸ್ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ ನಿಮ್ಗೆ, ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್. ಓಕೆನಾ? ನಾವ್ ಟು ದಿಸ್ ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್ ಐ ವಿಲ್ ಬಿ ಆಡಿಂಗ್ HCl. ನಾವು HCl ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಜೊತೆಗೆ ಈ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್ಗೂ HCl ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಪ್ರಾಡಕ್ಟ್ ಏನ್ ಬರುತ್ತೆ? When you take this carbon-carbon double bond, we know that the hydrocarbons carrying multiple bonds, they undergo addition reactions. They undergo addition reaction. Andre, the attacking reagent will get added to carbon-carbon containing double bond. Okay na? So H will be added to one of the carbon, chlorine will be added to one of the carbon. The question is, can H and chlorine be added to any of these two carbons? Athwa ide carbon ge add agbeku anta rules idiya? ಹೇಳ್ಬೋದಾ? Yes? To symmetrical alkene, this HCl can be added to any of the carbons. ಯಾಕೆಂದ್ರೆ it is identical. ನೀವೆಲ್ಲಕ್ಕೆ ಬೇಕಾದ್ರೂ add ಮಾಡ್ಬೋದು. We get the same product. So for example, we get RCH2, CHCl, this is R ಅಂತ ಇಟ್ಕೊಳ್ತೀನಿ. ಓಕೆನಾ? So hydrogen is added to this carbon and chlorine is added to the another carbon. But unsymmetrical alkene ತಗೊಂಡ್ರೆ ನೀವಿಲ್ಲಿ, if you observe, the HCl is added to carbon containing double bond. ಅದ್ರಲ್ಲಿ ಡೌಟ್ ಬೇಡ. ಇಲ್ಲಿ ನಮಗೆ ಶುರು ಆಗುತ್ತೆ. is hydrogen added to, for example, let me number, this is carbon 1 and carbon 2 ಅಂತ ಹಾಕೊಳ್ತೀನಿ. Is hydrogen added to carbon number 1 or hydrogen added to carbon number 2? ಎರಡು ಪಾಸಿಬಿಲಿಟಿ ಇದೆ. ಹಾಗೆ ಕ್ಲೋರಿನ್ ಕ್ಯಾನ್ ಬಿ ಆಡೆಡ್ ಟು ಕಾರ್ಬನ್ 1, ಕ್ಲೋರಿನ್ ಕ್ಯಾನ್ ಬಿ ಆಡೆಡ್ ಟು ಕಾರ್ಬನ್ 2, ಅದು ಪಾಸಿಬಲ್ ಇದೆ. ಬಿಕಾಸ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಆಡೆಡ್ ಆನ್ ಐದರ್ ಸೈಡ್, ಯಾಕೆ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್. ಹಾಗಿದ್ದಾಗ ಹೌ ಟು ಡಿಸೈಡ್ ಅಂದ್ರೆ ಎರಡು ಪಾಸಿಬಿಲಿಟೀಸ್. If H is added to first carbon and chlorine is added to second carbon, I get RCHCl, CH3 ಬರುತ್ತೆ. ಇನ್ನೊಂದು ಕೇಸ್ ಏನು, H will be added to second carbon, chlorine is added to first carbon. So I get RCH2, CH2, Cl ಬರುತ್ತೆ. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಎರಡೂ ಪಾಸಿಬಿಲಿಟೀಸ್. ಬಟ್ ಇಲ್ಲಿ ಪ್ರಶ್ನೆ, ಎರಡೂ ಈಕ್ವಲ್ ಆಗಿರುತ್ತಾ? Do we get these two products in equal proportion? ಅಂದ್ರೆ 50-50% ಇರುತ್ತಾ? ಇರಲ್ಲ. ಓಕೆನಾ? ಅವಾಗ you should think of one of the very important rule which governs the addition of the attacking reagent to an alkene, which is Markovnikov addition rule. Markovnikov rule. ಸೊ ಈ Markovnikov ರೂಲ್ ನ ಹೇಗ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು? ಅದಕ್ಕೊಂದು ಸಿಂಪಲ್ ಟ್ರಿಕ್ ಇದೆ. NaCl ಅಂತ ನಾನು ನೆನ್ಪಿಟ್ಕೊಳ್ತೀನಿ ಯಾವಾಗ್ಲೂ. NaCl ಅಂತ ನೆನ್ಪಿಟ್ಕೊಳ್ತೀನಿ. ಏನಂದ್ರೆ NaCl ಅಂದ್ರೆ ಏನು ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಕರೆಕ್ಟ್ ಆಗಿ. ನೆಗೆಟಿವ್ ಪಾರ್ಟ್ ಆಫ್ ದ ರಿಯೇಜೆಂಟ್ is added to carbon containing less number of hydrogen. I repeat, negative part of the reagent is added to carbon containing less number of hydrogen. That is a simple trick to remember Markovnikov rule. When I say negative part, in HCl irbodu, HBr irbodu, HI irbodu, we know that halogens are more electronegative. Therefore, the chlorine ಅಥವಾ halogen atom, they carry negative charge and hydrogen will always carry positive charge. Correct? So now, which is the negative part in HCl? It is chlorine. So it is chloride ion now, carrying minus charge irodrinda it is chloride ion. So negative part, that is Cl minus, is added to carbon containing less number of hydrogen, which is second carbon. Therefore, among the first product and the second product, which product only the chlorine, that is Cl minus ion, is bonded to carbon containing less number of hydrogen? First one or second one? Yes? Which is the major? Yes, students, I'm waiting for your reply. Negative part of the reagent is added to carbon containing less number of hydrogen. So negative part yaudilli Cl minus. So Cl minus should be added to carbon containing less number of hydrogen. Andre yav carbon? No. Is it first carbon or second carbon? It is second carbon, because this is having only one hydrogen. The first carbon is having two hydrogens. Therefore, the chloride ion, that is Cl minus, will be bonded to carbon containing less number of hydrogen, that is second carbon. Therefore, this will be the major product, which is major now, and this is minor. Artha aita? Artha aita? Yes, students. ಡೌಟ್ ಇದೆ ಯಾರಿಗಾದ್ರೂ? ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೋಣ ಈಗ ಇದಕ್ಕೆ. If I take CH2 double bond CH2, which is ethene, this is symmetrical alkene. To this symmetrical alkene, now I am adding HCl. ಏನ್ ಬರುತ್ತೆ ಪ್ರಾಡಕ್ಟ್? Symmetrical alkene plus HCl. So H and Cl can be added to any of this carbon because it is symmetrical. Therefore, we get only one product, CH3, CH2, Cl ಬರುತ್ತೆ. That is chloroethane ಬರುತ್ತೆ. But other, if you take a different alkene which is unsymmetrical, for example CH3, CH double bond CH2 plus HCl ಅಥವಾ HBr ಹಾಕೋಣ ಇವಾಗ, ಏನ್ ಬರುತ್ತೆ? ಪ್ರಾಡಕ್ಟ್ ಏನ್ ಬರುತ್ತೆ? one product ಬರುತ್ತಾ, ಎರಡು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತಾ? Do we get one product or two products here in this reaction? Very good, we get two products. And which is major? Can you name the major product that we get? Propene plus HBr. So in HBr, H is carrying positive charge, Br is carrying negative charge. So Br minus should be bonded to carbon containing less number of hydrogen according to Markovnikov's rule, and that product will be the major product. Therefore, we get CH3, CH, Br, CH3. Another product ಏನು ಬರುತ್ತೆ? CH3, CH2, CH2, Br. ಎರಡು ಬರುತ್ತೆ. But the first one is the major one, which is 2-bromo-propane. Very good, Pooja. Hope I made this clear. ಏನಾದ್ರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ? ಏನಾದ್ರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ? Yes? ಇವಾಗ ನೋಡಿ, I have taken the same propene, same attacking reagent HBr, but in addition to that, I'm using another substance here, which is peroxide. So in the presence of peroxide, the addition of HBr to an unsymmetrical alkene, ಇದು addition reaction है. But do you think it will follow Markovnikov rule? NPDR first year concept ಇದು. Do you think HBr will get added to carbon containing double bond in accordance to Markovnikov rule? Yes or no? Yes? ಇಲ್ಲ. ಹಾಗಾದ್ರೆ ಹೇಗೆ ಅಡಿಷನ್ ಆಗುತ್ತೆ? ಹೇಗೆ ಅಡಿಷನ್ ಆಗುತ್ತೆ? I'll write the product first. We get CH3, CH2, CH2, Br ಬರುತ್ತೆ. This is the product that we get. ನೀವು ಕೇರ್ಫುಲ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಬರೀ ಪರಾಕ್ಸೈಡ್ ಚೇಂಜ್ ಮಾಡಿದ್ದಕ್ಕೆ addition itself is different. ಇಲ್ಲಿ the negative part we have H plus and Br minus. The Br minus is added to carbon containing more number of hydrogen. Correct ಅಲ್ವಾ? But according to Markovnikov rule ಏನು ಹೇಳ್ತೀವಿ? The negative part should be added to carbon containing less number of hydrogen. But in the presence of peroxide, the rule is converse. The addition is converse, where the negative part of the reagent is added to carbon containing more number of hydrogen, and that addition we call it as anti-Markovnikov addition. Anti-Markovnikov addition ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? And ಈ reaction ನ we also call it as peroxide effect or Karash effect. This reaction we also call as peroxide effect or Karash effect ಅಂತಾನು ಕರಿತೀವಿ. This is very important, and this reaction will go via the formation of free radical mechanism ಅಥವಾ free radical addition reaction. Very important for a competitive exams. And remember, Karash effect ಅಥವಾ peroxide effect ಅಥವಾ anti-Markovnikov addition is only applicable for HBr. Okay? ನೀವು HCl HI ತಗೊಂಡ್ರೆ that will not follow anti-Markovnikov addition. So it will follow only Markovnikov addition. Okay na? But only HBr in the presence of peroxide will follow anti-Markovnikov addition. Is that clear, students? This is very important. Any doubts idea? Do you have any doubts? Do you have any doubts, students? I'll take just 5 more minutes to complete all the preparations. Last method from halogen exchange. Halogen exchange method. ಇದರಲ್ಲಿ ಎರಡು reaction ಇದೆ. The first one is Finkelstein reaction. Finkelstein reaction, one of the very important method for the preparation of iodoalkanes. It is used for preparation of iodoalkanes. Okay na? ಸೊ ಏನ್ ಹಂಗಂದ್ರೆ ಫಿಂಕಲ್ಸ್ಟೀನ್ ರಿಯಾಕ್ಷನ್ ಗೊತ್ತಿದೆಯಾ? ಹೇಳ್ಬೋದಾ ಯಾರಾದ್ರೂ? ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಫಿಂಕಲ್ಸ್ಟೀನ್ ರಿಯಾಕ್ಷನ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ಎಸ್. ಸೊ ವೆನ್ RBr ಇರ್ಬೋದು ಅಥವಾ RCl, RBr or RCl upon reacting with sodium iodide in the presence of acetone as a solvent, so there will be formation of Ri. I told you it is used for the preparation of iodoalkane. Therefore, there will be formation of Ri plus NaBr plus NaBr. ಹಾಗೆ ನೀವು RCl ಯೂಸ್ ಮಾಡಿದ್ರೆ RCl plus NaI, sodium iodide, they react in the presence of acetone to give what? To give what? Yes? Yes, students. What do we get? We get Ri plus NaCl. So we prepare iodoalkanes by using this method, that is Finkelstein reaction. And always remember, named reactions are very, very, very important reactions for all your exams. ಅದು ಬೋರ್ಡ್ಸ್ ಎಕ್ಸಾಮ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಆಗಿರ್ಬೋದು, ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ತುಂಬಾ ಅಂದ್ರೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಅದನ್ನ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಚೆನ್ನಾಗಿ. ಅಂಡ್ ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಬೆಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್, ಐ ಮೀನ್ ಒನ್ ಆಫ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ರಿಯಾಕ್ಷನ್ ಫಾರ್ ದ ಪ್ರಿಪರೇಷನ್ ಆಫ್ iodoalkanes. So examples na ನೀವೇ ಟ್ರೈ ಮಾಡ್ಬೇಕೀಗ. So you can take different alkyl halides like alkyl bromides and alkyl chlorides ತಗೊಳ್ಳಿ, NaH ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿ, ನಿಮ್ಗೆ ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ನೀವು ಬರೀಬೇಕು. ಓಕೆನಾ? And last reaction, that is Schwarz reaction. So similarly, when you take Finkelstein reaction, it is used for the preparations of iodoalkanes. Correct? Again, this Schwarz reaction is used for the preparation of fluoroalkanes. Fluoroalkanes ನ ಪ್ರಿಪೇರ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಮುಂಚೆ ನಾವ್ ಯಾವ್ದೂನು fluoroalkanes ನ ಪ್ರಿಪೇರ್ ಮಾಡಲಿಲ್ಲ. So this is one of the very, very, very important method for the preparation of fluoroalkane, that is Schwarz reaction. So ನಾವಿಲ್ಲಿ we take either alkyl chloride ತಗೊಳ್ತೀವಿ ಅಥವಾ alkyl bromide ತಗೊಳ್ತೀವಿ. Let me take RCl, alkyl chloride. This is made to react with different metal fluorides. Metal fluorides ಏನೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ AgF ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಥವಾ Hg2F2 ಮರ್ಕ್ಯುರಸ್ ಫ್ಲೂರೈಡ್ ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಥವಾ cobalt trifluoride ಯೂಸ್ ಮಾಡ್ಬೋದು, COF3. ಸೊ ಈ ತರ ಬೇಕಾದಷ್ಟು ರಿಯೇಜೆಂಟ್ಸ್ ಇದೆ. ಸೊ ದೀಸ್ ರಿಯೇಜೆಂಟ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್, COF2 ಯೂಸ್ ಮಾಡ್ತೀವಿ, SbF3 ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆನಾ? ಸೊ ಯಾವ್ದಾದ್ರು, ದೇ ಆರ್ ಆಲ್ ಮೆಟಲ್ ಫ್ಲೂರೈಡ್ಸ್, ಬಿಕಾಸ್ ಸಿಲ್ವರ್, ಮರ್ಕ್ಯುರಿ, ಕೊಬಾಲ್ಟ್, ಸ್ಟಿಬಿಯಂ ಇದೆಲ್ಲ ಮೆಟಲ್ಸ್ and the respect to metal fluorides. So metal fluorides they react with either RCl ಅಥವಾ RBr. Okay na? To give what? To give what? ಹೇಳ್ಬೇಕು. And acetone ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ ಇಲ್ಲಿ ಸಾಲ್ವೆಂಟ್ ಆಗಿ. Very good. We get RF ಬರುತ್ತೆ. We get RF as a product. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋಣ. CH3, CH2, Cl plus AgF in the presence of acetone. So product ಮತ್ತೆ by product ಏನ್ ಬರುತ್ತೆ ಹೇಳ್ತೀರಾ? Very good. Byproduct is AgCl and the product is CH3, CH2F plus AgCl. Simple. Okay na? Any doubts? And exams ಅಲ್ಲಿ ಡೆಫಿನೇಷನ್ಸ್ ಬರೆಯೋದು ತುಂಬಾ ಈಸಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ನಲ್ಲಿ, ಎಸ್ಪೆಷಲಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಯಾಕೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಜನರಲ್ ರಿಯಾಕ್ಷನ್ ಗೊತ್ತಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ರೈಟ್ ದ ಡೆಫಿನೇಷನ್ ಔಟ್ ಆಫ್ ಇಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ನೋಡಿ, ವೆನ್ ಆಲ್ಕೈಲ್ ಕ್ಲೋರೈಡ್ಸ್, ಆಲ್ಕೈಲ್ ಬ್ರೋಮೈಡ್ಸ್ ಆನ್ ರಿಯಾಕ್ಟಿಂಗ್ ವಿತ್ silver AgF, silver fluoride ಅಥವಾ mercurous fluoride HDF2, we get fluoroalkane. This reaction is known as Schwarz reaction. ಈ ತರ ಸೊ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ನ ಕಂಬೈನ್ ಮಾಡಿ ಸಾಲ್ವೆಂಟ್ ಏನಂತ ಹೇಳಿ, ಪ್ರಾಡಕ್ಟ್ ಏನಂತ ಹೇಳಿ, ಯು ವಿಲ್ ಗೆಟ್ ದ ಡೆಫಿನೇಷನ್. ಓಕೆನಾ? ಎನಿ ಡೌಟ್ಸ್? ಎನಿ ಡೌಟ್ಸ್? Any doubt, students? So these are the important methods of preparations of haloalkanes. So we have discussed 4 methods. From alcohols discuss madidvi, from alkanes, from alkenes, and from halogen exchange method. Okay na? So these are the very 4 important methods. You don't write the AgCl, sir. Elli? Mr. Shivraj, where? In the general reaction. So AgF use ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ RF ಬರುತ್ತೆ. ಅದೇ ನೀವು Hg2 F2 ಯೂಸ್ ಮಾಡಿದ್ರೆ once again ನಿಮ್ಗೆ RF ಬರುತ್ತೆ, ಬಟ್ ಬೈ ಪ್ರಾಡಕ್ಟ್ ವಿಲ್ ಬಿ Hg2 Cl2 ಬರುತ್ತೆ. ಸೊ ಡಿಪೆಂಡ್ಸ್ ನೀವು ಏನ್ ಮೆಟಲ್ ಫ್ಲೂರೈಡ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ, ಸೊ ರೆಸ್ಪೆಕ್ಟಿವ್ ಮೆಟಲ್ ಕ್ಲೋರೈಡ್ ಅಥವಾ ಮೆಟಲ್ ಬ್ರೋಮೈಡ್ಸ್ ಬರುತ್ತೆ. ಅದಕ್ಕೆ ನಾನು ಜನರಲ್ ಆಗಿ ಬರ್ತಿದ್ದೀನಿ ಅಷ್ಟೇ. ಅದಕ್ಕೆ ಐ ಟೇಕನ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್ ವಿತ್ AgF. AgF ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ವಿ ಗೆಟ್ AgCl. ಅದೇ if you take the same one, CH3CH2Cl plus Hg2F2 in the presence of acetone. So ನಿಮಗೆ ಬರೋ ಪ್ರಾಡಕ್ಟ್ CH3CH2F ಫ್ಲೂರೋಯಿಥೇನೆ ಬರುತ್ತೆ, ಬಟ್ ಬೈ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ Hg2Cl2 ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಟು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ಕೆ we have to multiply by 2 here. Hope I made this clear. Shivraj, doubt ಇದೆಯಾ? ಯಾವ್ದಾದ್ರು ಯೂಸ್ ಮಾಡ್ಬೋದು. ನೀವೇನ್ ಮೆಟಲ್ ಫ್ಲೂರೈಡ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅದ್ರ ಬೇಸಿಸ್ ಮೇಲೆ ಬೈ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ. ಓಕೆನಾ? ಬಟ್ ಪ್ರಾಡಕ್ಟ್ ಬಂದು ನಿಮಗೆ ಬರೋದು ಫ್ಲೂರೋ ಆಲ್ಕೇನೆ. ಎಸ್ ಶಿವರಾಜ್, ಡೌಟ್ ಇದೆಯೇನಪ್ಪ? Okay then, thank you. So this is with respect to the methods of preparations, and this is all about today's session. So ivatte ella reactions na practice ಮಾಡಿ, ಒಂದು take a sheet of paper and try to make a point out of it. ಒಂದೊಂದೇ methods of preparations heading ಆಗಿ general reactions ಬರೀತಾ ಹೋಗಿ. So within half a sheet you can complete all these methods of preparations, and this will help you a lot when you sit for revision. ಓಕೆನಾ? ಸೊ ಅದನ್ನ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ತುಂಬಾ ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ, ಆರ್ ಎಲ್ಸ್ ವಿ ಕ್ಯಾನ್ ವೈಂಡ್ ಅಪ್ ದ ಸೆಷನ್. ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದೆಯಾ? Anybody in the class? Yes, Jairaj. No doubts. Thank you then. So shall we wind up the class?
Thank you, sir. Thank you very much.
Thank you, sir. Thank you, dear students. So do practice all the reactions what we discussed so far, and take different examples and try out. Okay na? So thank you everybody. Thank you once again.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಮಕ್ಕಳಿಗೆ ಬಾರಿ ಸರಳವಾಗಿ ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಎರಡರಲ್ಲೂ ಕೂಡ ಹಲವಾರು ಕ್ವಶನ್ಸ್ ಪ್ರಶ್ನಾವಳಿಗಳ ಮುಖಾಂತರ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮನ ಬಹಳ ತಿಳಿಯಾಗಿ ಮಕ್ಕಳುಗಳಿಗೆ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಾ. ಸೊ ಅದೇ ರೀತಿ ಮಕ್ಕಳು ಕೂಡ, ಸ್ಟೂಡೆಂಟ್ಸ್ ಕೂಡ ಇಂಟ್ರಾಕ್ಟ್ ಆಗಿ ತಮಗೆ ಗೊತ್ತಿದ್ದಂತ ಕರೆಕ್ಟ್ ಉತ್ತರಗಳನ್ನ ಅವರು ನಿಮಗೆ ಒಂದು ಚುಟುಕು ಸಂದೇಶದ ಪ್ರಕಾರ ಕೊಟ್ಟಿದ್ದಾರೆ.
Yes sir.
I would thank you immensely to deliver a very informative and insightful talk on today's topic behalf of KSTA and myself. Thank you, sir.
Thank you so much, sir. Thank you, dear all students. So we'll meet in the next session. Okay na? Thank you.
So then you continue ಇದೆಯಾ ಸರ್? ಬೇರೆ ಏನಾದ್ರು ಟಾಪಿಕ್ ಆಗ್ತಿದೆ?
ಇಲ್ಲ, ಅಂದ್ರೆ ಈ ಚಾಪ್ಟರ್ ಮಾಡಿ ಅಂದ್ರೆ ನಾನು ಮಾಡ್ಕೊಳ್ತೀನಿ. ಮಕ್ಕಳಿಗೆ ಹೆಂಗ್ ಬೇಕು ಅಂದ್ರೆ ಅವ್ರ ಬೇಸಿಸ್
ಇದನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಕೊಟ್ಬಿಡಿ ಸರ್. ನಾನು ಅನದರ್ ಡೇಟ್ ನಾನು ಫಿಕ್ಸ್ ಮಾಡಿ ತಮ್ಗೆ ಹೇಳ್ತೀನಿ.
ಖಂಡಿತ ಸರ್,
ತಿಳಿಸ್ಕೊಡ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್.
ಮತ್ತೆ ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಿದ್ದ ನನ್ನ ಎಲ್ಲಾ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಅಧ್ಯಾಪಕರು, ಶಿಕ್ಷಕರು ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಾ, ನಾಳಿನ ಸಂಚಿಕೆಯಲ್ಲಿ ಸಿ ಚೇತನ್ ರವರು ತಮಗೆ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದಾರೆ. ಎಂದಿನಂತೆ ಇವತ್ತು ಯಾವ ರೀತಿ ಸರ್ ಜೊತೆ ಇಂಟ್ರಾಕ್ಷನ್ ಆಗಿದ್ರೋ ಅದೇ ರೀತಿ ಚೇತನ್ ಅವರು ಕೂಡ ಕೋಆಪರೇಟ್ ಮಾಡಿ ನಾವು ಆ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಇಂದಿನ ದಿನಕ್ಕಿಂತ ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ಮಕ್ಕಳು ಹಾಜರಾಗಬೇಕು ಅಂತ ನಾನು ಮತ್ತೊಮ್ಮೆ ನಮ್ಮ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ಎಲ್ಲರಿಗೂ ತಿಳಿಸುತ್ತಿದ್ದೇನೆ. ಥ್ಯಾಂಕ್ ಯು ಒನ್ ಅಂಡ್ ಆಲ್. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್.